In today's tutorial, we will have a look at statistical product distribution. Let's assume we have a molecule with two identical functional groups, abbreviated with G, connected by a tether. And we have a reagent A, which we apply with an amount of 1 equivalent. And this reagent A should be capable for an addition reaction at these functional groups. So what we expect, and this should be our target molecule, is this one, where an addition process had occurred at one of the two functional groups. However, imagine as soon as the one group has reacted, there is still lots of reagent A in the reaction mixture. Therefore, also the second group A could react. Then it would lead to the product where both functional groups have reacted. And as soon as all A is consumed, then, some of the starting material, of course, will remain. What distribution would we anticipate? Well, there is the possibility that this one is formed. Let's write down a 1. Here also the possibility that both have reacted. But there are two pathways for the formation of this product. Either this group G has reacted, or the other one. Both lead to the same product. Let's write down a 2. The product distribution is 2 to 1 to 1, or translated in 50%, 25%, and 25%. So here we have another example, not an addition process, while initially it has something to do with the addition of sodium hydroxide to the ester functionality within the reaction mechanism of the hydrolysis. So we apply one equivalent of sodium hydroxide for the hydrolysis of the ester functionality, two esters connected here. And again, what we should anticipate is finally a mixture of the starting material, the monohydrolyzed product, and the bishydrolyzed product in the ratio 1 to 2 to 1, translated to 25%, 50%, and again 25%. So how could we increase the formation of the target molecule, the monohydrolyzed product? Well, for instance, in using a rather unpolar reaction medium, an unpolar solvent. In an unpolar solvent, the D ester should be soluble just fine. On the other hand, as soon as one ester functionality is hydrolyzed, this is highly polar and less soluble within the unpolar solvent. It will fall out, maybe crystallizing out of the reaction mixture, and therefore then the hydrolysis of the second ester functionality should be inhibited. This is just one example of proceeding tricks one could apply to go selectively for the target molecule. Thanks for listening.